Hello, this is the our subject name is electronics device and circuit. Up to here, we have discussed about the clamper circuit previous bit of our lectures, and s- and that clamp we have also discussed the basic functions of the clampers, and in this class we will continue the clampers. So what are the clampers? An electronic circuit that used to alter the positive or negative peak signal and input signal to a definite value, shift entire signal up and down this signal desired. After we have discussed the definition and working of this, so the positive or negative peak signal can be positioned at desired level, means positive portion or negative portions we can shift our requirement. So such circuit are called clamping. Clamping means shifting the level from one up and down. So we can shift the level of peak signals by using clamper. Hence means we want to shift our level from one position to another position. Clamper circuit are combination of diode resistors. This is the combination of diode and resistors in parallel across the clamper circuit depend on the change in time constant of capacitors and resistor are used. The capacitor must be chosen so that the duration of conduction of diode and capacitor must be sufficient to charge quickly. During the non-conducting period of diode, means conduction periods, the of the within a conduction period, the capacitor must be charged. That's in this way its time constant capacitors. In this way, this kind time constant RC must be decided. If the diode is disconnected, so thus it must be discharged according to this RC. The time constant is RC. दूसरा clamper are classified as positive and negative clampers. Actually, we have discussed this in our previous lectures. That's why we will discuss just working of this negative clamper. Clamper means diode and capacitor, combination of diode and capacitor. Means this is the combination of diode and capacitor. So during the positive half cycle, during the positive half cycle, this diode will on. So how this during the positive half cycle, this diode become like short circuit. Means this path is will be completed during the positive half cycle. And capacitor start to charging. This is the supply terminal like Vi input of this. So capacitor charge to charging like this. So use the KVL in this loop. Then you use this plus Vi minus Vc. Vc the voltage across the capacitor equal to 0 using the KVL. So Vc voltage across the capacitor will be Vi. This during the positive half cycle, this capacitor will charge up to Vi voltage. Then again during the negative half cycle, the same circuit will change. This is the capacitor. This is the V input, V V input, and this is the positive VI. VI the capacitor charge हो जाएगा up to VI. Here diode become to off during the negative cycle. The diode will be reverse bias. Why? Because negative supply is comes on here. Negative is like this until the positive. So this circuit will look like this. As is during the positive half, that forward wise डायोड कंडक्ट कैपेसिटर गेट चार्ज अप टू पीक vi, अप टू vi तक चार्ज हो रहा है. ड्यूरिंग द नेगेटिव हाफ साइकिल the reverse the reverse does not conduct and output voltage become equal to sum of an input voltages. Means this is the output voltages here. If we are output voltages here, then we can use the again KVL. If we so then this is the minus vi, this is the again minus vi, this is the again minus vi, this is the minus vi, this is again minus v0 equal to 0. V0, what is V0 minus Vi? Previously we have discussed the output was 0 and capacitor was charging and voltage become to sum of input voltage and voltage stored across the capacitor. Negate, so how will this will how this will like open. Suppose that this is the our circuit. Input is this, output. During the positive half cycle, then V output is equal to 0. Suppose that input is 0, then input start to suddenly increasing. Maximum Vi, that time output must be, this time output must be 0. Positive half cycle output must be same. Output, this output must be 0. In negative half cycle output must be 2 Vi. Minus output was the minus 2 Vi. That's why the minus 2 Vi. Vi is always negative, so negative must be positive. That's why it must go into, this is the 2 Vi. This is the input shifted here up to minus Vi. So then in Vi, in this way it moved to upward direction. So this is the application of clampers. This is a complex transmission and receiver circuitry. Television used as a baseline, defined a sectional of illumination. Similarly, this is a positive clamper. Similarly, this is a negative clamper. Same way, first initial. This is the, this we have discussed up to here. This is the positive clamper. We have again previously we have discussed the negative clamper. In Vi, when Vi 0, we will talk about the positive. This positive half cycle. This is the, suppose that we have derived this equation positive half cycle, because this is the positive half cycle. I think we are not able to draw this diagram. This is the positive half cycle. Listen, suppose Vi 0 है, input is 0, initially capacitors Vi, V output equal to Vi, and V0, because positive half cycle this is short, so V0 is short. जब input, हाँ, this diagram I think something is wrong here. This is the output. Suppose that when input up to Vi, up to Vi here, point say ideal diode, up to output must be what? Output must be 0. Output must be 0. You can see during the during the positive half cycle, diode is forward bias and diode conduct capacitor gets charged up to V input supply. During the negative half cycle, The reverse cycle, the reverse diode does not conduct, and reverse bias reverse doesn't conduct, and output become to equal to sum of input voltage and storage across the capacitor. So here this level is shifted down. This level is shifted down to here, minus VC minus VI again, 0 to one level shifted minus VI, because when VI is 0, then output